students, it's me, and I'm back with lesson 9.5C, which is factoring trinomials. Our essential question for today is how to factor trinomials. Now, we're going to continue to use the skills from the earlier lessons that we learned in 9.5A and 9.5B. If you've not watched those lessons yet, please go back and do that as they will be referenced here. If you remember, we learned in 9.5A that sometimes you need to factor out a GCF or a greatest common factor. This is true anytime you are working with a situation where each term is divisible by the same value. We did not include that in the directions for yesterday's notes, which included factoring just trinomials. So in today's notes, I've added what I'm calling step 0, and that's factor out a GCF. Sorry, my straight line tool is not working very well right now. And so what that means is a greatest common factor, everything is divisible by that value. Okay? Step 1 of the process, if you remember, is just saying to identify the A, B, and C value. A is in front of the x squared, B is in front of the x, and C is all by itself. It does not have a coefficient. Step 2 is to create your magic questions, which is what adds to equal the middle number, or B, and what multiplies to equal A times C. For right now, we'll be using 1 for A in most of our situations. Step 3, and the final step of the process, is to fill in the box and factor. So if you remember, the ax squared term always goes in the top left corner. The C value goes in the bottom right-hand corner. And then the B term is composed of the combination of the two magic question numbers. And you'll notice when we write it over here, we attach an X to it. The reason we do that is because that is representing the middle term. And so when we combine those two boxes, it should equal BX in our sample here. So let's go ahead and take a look. I have 3 examples planned for us today. In example A, you'll see that we are factoring 2x squared plus 14x minus 36. As I look at all 3 terms, I notice that they are all even, which tells me that I can factor out a 2. If I factor out a 2, I'm left with x squared plus 7x minus 18. Now that I've factored out the GCF, I'm going to identify my A, B, and C values. Now, some students get confused which trinomial we are working with. Now that we've factored out the GCF, we're going to be focusing on the part that is showing up in the parentheses. So in this case, A is 1, B is 7, and C is negative 18. Now that we've identified those, I can figure out my magic questions. So I want to know what adds to 7 and multiplies to negative 18. I'm a big fan of writing out my factors. So 1 times 18, 2 times 9, and 3 times 6. Because I want it to multiply to negative 18, I know 1 is going to be positive and 1 is going to be negative. That lends itself towards 2 and 9, because negative 2 plus positive 9 equals 7. It also multiplies to negative 18. Now I can fill in my box. I like to put my magic questions in first, and I always attach the x to them. I'm going to place x squared in the top right or top left-hand box and negative 18 in the bottom right. Last, we'll factor out what's in common. X times x is x squared. What times x is 9x? That would be 9. What times x is negative 2x? That's negative 2. And I always check, is negative 2 times 9 negative 18? It is. We're good to go. Now, in the past, when we would write our answer, we would write x plus 9 times x minus 2. That's still the case. But don't forget, we factored out that GCF. So we need to make sure we write that GCF in as well. Let's take a look at example B. In example B, we are factoring x squared plus x minus 12. There is not a GCF between those values, so I'm going to jump into step 1, which is identifying the A, B, and C of the problem. A is 1, B is 1, and C is negative 12. Moving on to step 2, identifying my magic questions. What adds to equal 1 and multiplies to equal negative 12? As you know, I always list my factors because it helps me determine which factor pair is going to work best. After I've listed all my factors and I'm recognizing they need to multiply to negative 12, I'm going to choose to use my 3 and 4 factor. 3 and 4 have a difference of 1, and because I want one of them to be negative, I'm going to make the 3 negative because that is what adds to equaling 1. Placing those into the diagonals of your box and attaching an x to each will help me get to the point of being able to factor. Also, I need to add in x squared in the top left and negative 12 in the bottom right. Factoring out what is in common, x times x is x squared, x times 4 is 4x, and x times negative 3 is negative 3x. Always check that the remaining factor does indeed multiply out, in this case to negative 12. It does, so I can write my final answer of x plus 4 times x minus 3. All right, I have one more example for us. The last example is factor 3x squared plus 24x plus 48. So as I look at the three terms, I see very large numbers, which makes me worry, but I also recognize that they're all divisible by 3. When I factor out the 3, I'm left with x squared plus 8x plus 16. Now I'm going to focus on the parenthesis part when I identify my A, B, and C value. A is 1, B is 8, C is 16. So my magic questions are, what adds to 8 and multiplies to 16? Looking at my factors of 16, I know 1 times 16, 2 times 8, and 4 times 4. Because it's positive, both numbers will be positive or both numbers will be negative. In this case, 4 times 4 and 4 plus 4 fulfill the requirements. Filling in the box, I get 4x on the diagonal, x squared in the top left, and positive 16 in the bottom right. Factoring out what's in common, x times x is x squared, x times 4 is 4x, and 4 times 4 is 16. This particular polynomial factors to x plus 4 times x plus 4. And don't forget, we did factor out a GCF of 3, so we need to place that out front before stopping. I hope today's lesson on factoring helps you to solidify the process. Stay tuned. Next, we'll learn how to solve after you've factored.